Welcome to Chemical Process Safety. This video is about toxicology. Toxicity is a property describing an adverse effect on a biological organism. It is one type of chemical hazard, along with flammability, explosivity, and corrosivity, to name a few others. However, not all toxicants are necessarily chemicals. Dust and noise also fit this definition. I challenge you to pause the video now and think of as many toxic substances as you can. I'll give you a few seconds. And I'm willing to bet that you thought of chemicals like mercury, carbon monoxide, hydrogen cyanide, or maybe even ricin. But I'll bet that you never thought of a substance like water as a toxicant, did you? Surprisingly, water toxicity is actually a thing. This brings about an interesting fundamental principle of toxicology, which states there are no harmless substances, only harmless quantities of substances, or harmless ways of using substances. In order to defend against toxicological hazards, there are several things we need to know. First, we need to know the routes that toxicants can enter your body. There are four main ways: ingestion, or through your mouth and digestive system; inhalation, or through your respiratory system; injection, meaning through needles, sharp objects, or cuts; and dermal absorption, meaning through your skin. This plot shows how the bloodstream composition might vary depending on the entry route, with all else equal. Injections and inhalations raise the bloodstream composition the fastest, and injections deliver more of the toxicant relative to anything else. On the other end, dermal absorption is the slowest and lowest level, indicating that the skin is generally a good barrier against many toxicants, but of course it depends on which toxicant. This knowledge helps inform which safeguards to implement. For example, for inhalation hazards, a ventilation system would be appropriate, while for injection hazards, protective clothing is better. Secondly, understanding the effects on the body can help us answer the question of how bad could it be. Words to look for on the safety data sheet that describes which organ a toxicant affects are: dermatoxic, affects skin; hemotoxic, affects blood; hepatotoxic, affects liver; nephrotoxic, affects kidneys; neurotoxic, affects nervous system; and pulmonotoxic, affects lungs. Other indicating words to look for are carcinogenic, meaning causes cancer, and mutagenic, meaning causes chromosomal damage. Note the subtle difference between these two. Third, we might want to understand how the body attempts to eliminate toxicants. The primary means is excretion, which just means rejected as waste. For example, the kidneys could excrete the toxicant and remove it in urine, or your lungs could excrete the toxicant with exhalation, or it could leave through your skin in sweat. Another route is detoxification, in which the liver chemically converts the toxicant into something harmless. Finally, the toxicant could be stored in fat cells, which might become a problem later on if the fat is metabolized. Lastly, the quantity of toxicant required to produce an adverse effect is possibly the most important thing we'd want to know. But this topic has some nuance, so let's cover it next time on Chemical Process Safety.